Hello, welcome to my YouTube channel. Today we are going to find minimum and maximum number of nodes between critical points. Critical point in a linked list is defined as either a local maxima or a local minima. A node is a local minima if a current node has the value strictly greater than previous node and the next node. A node is local minima if the current node has a value strictly smaller than the previous node and the next node. Note that a node can only be local minima or maxima if there exists both a previous node and a next node. That's a very important information. So if you have a linked list with only two elements, we cannot have a critical point. Given a linked list head, return an array of length 2 containing min distance and max distance, where min distance is the minimum distance between any two distinct critical points, and max distance is the maximum distance between any critical distinct points. If there are fewer than two critical points, return the array -1 for min and max. For example, in this example, we have no critical point since we have only two elements in a linked list. But in this example 2, we have three critical points. The first one is 1, which have index 3. The second one is the fifth node, 5, because 5 is greater than 2, and 1. Here 1 is smaller than 3 and 2, so that's why it's critical point. 1 also is less than 5 and 2, so it's a critical point. And to find the minimum distance between which of this, it will be the difference between fifth node and the sixth node, which is 6 minus 5, so it's 1. The maximum difference between the first node, which is the third, and the sixth node, which is 6, so it is 3. So to solve this problem, we can iterate through the linked list from its head, and we will keep track of 6 things. The first one will be the current node, the previous node, the position of the current node, the position of the previous critical point, the position of the first critical point, and the minimum distance, which will update for each pair of consecutive critical points. So let's see this image. Here we have 1 has a critical point, 5 has a critical point, and 1 has a critical point. So the first element is 1, the first critical element is 1, and the last one is also 1. So this position is 3, and this position is 6. So the maximum will be 3. But you can see in blue what will represent the distance between the first and the last critical point. So that will be the max, and the min is the one in red. So it will be between, the minimum will always be calculated for each pair of consecutive critical points. For example, 1 and 5 and 5 and 1. So we take the smallest. So let's dive into the coding. So we'll initially have the array result that will have -1. So we initialize the minimum with the maximum possible value, which is infinity. The pointer, previous, current node, and index. So we'll have previous node will be head, the current node will be head next, and the current index will be 1. Let's start with index 1. Previous critical index is 0, and the first index is 0. So we'll iterate through the linked list if the current index is not null. So we'll iterate up to the last element before the second to last element in the linked list. So we'll stop at this example 1. So if the current element is less than the previous element, the current element is less than the current element the next element to the current. Like in this example, 1 is less than 3, 1 is less than 2. So 1 is a critical point. Or if the current element is greater than the previous one, and also greater than the next element to it, like in this example, 5 is greater than 2, 5 is greater than 1. So if any of those two condition holds, then we'll update. We'll check first if this is the first time you encounter a critical point. So if previous critical index is 0, so we'll update to current index, and so that will correspond to the first critical point. Else, if this is not the first critical point, we'll calculate the minimum distance. So it will be the mean between the minimum distance, the current index minus the previous index. So then we'll update the critical index to be current, and you'll also move to the next head and update the index. Previous node will point to the current node, and current node will point to the current node next. So we'll move. So head was here, current node was here, current node here. So we'll just move head to here. Previous will be here, current node will be here, current node next will be 2. So when you reach the end of the linked list, then we'll check if the minimum distance has been updated. Then we calculate. Here we are checking if it has been updated, meaning you have at least 2 critical points, because this minimum distance cannot be updated if you don't have more than 2 critical points. Then the max is calculated using the last element and the first element. So result will be updated. Then we return result. So let's run this. That is it for today. Please subscribe, share, like.